So next we have is a phase shift oscillator. Okay, so for this phase shift oscillator, the block diagram is we have an amplifier. Okay, so here this is grounded, this is grounded. Input is measured with respect to the ground. Okay, so it is connected with a feedback, and this feedback, it is consisting of a ladder which is made up of resistors and capacitors. So this is R feedback network consisting of RC network. Okay, so this is VI and this is your V0. Okay, so this represents block diagram of basic phase shift oscillator. Okay, I'm just saying it is phase shift oscillator. So the phase shift oscillator can be constructed by using it may be op-amp or it may be using transistor. So this amplifier part is there, no? This can be constructed by using either op-amp or it can be transistor, any of the both, any of one. Okay, with the same feedback network. Feedback network, it will remain same, only amplifier part it can be replaced by either a transistor or an op-amp. Okay, this is also called as RC phase shift oscillator. Why? Because your feedback network, it is made of RC network, isn't it? That's why the name it is called as RC phase shift oscillator. The circuit consisting of an amplifier and a feedback network consisting of resistors and capacitors arranged in ladder fashion. Can you observe? It is arranged in ladder fashion. Hence, such an oscillator, it is also called as ladder type RC oscillator. Ladder type RC oscillator. This is the RC phase shift oscillator. This is the other name. Okay, this is the other name for a phase shift oscillator. So this diagram represents, it is a block diagram of phase shift oscillator. So it is consisting of amplifier and a feedback network which is made up of resistors and capacitor, wherein the resistors and capacitors are arranged in a ladder format. Hence it is also called as ladder type RC phase shift oscillator. Okay, as I said, this amplifier can be either op-amp or it can be a transistor. I'll just show you the circuit, how it is made up of op-amp, that is operational amplifier. So that in detail you will be going to study in your third module. Okay, third module, it is completely of operational amplifier that you will be going to study. So how you can write op-amp as an amplifier. Okay, this is V0, this is feedback resistance, this is R1 resistance, input resistance. So this is 3 RC networks you have, which is nothing but a feedback network. Okay, so this how it looks like when RC phase shift oscillator using RC phase shift oscillator using op-amp. This is using op-amp. Okay, the same we can write using transistor also. How you can write transistor? So this circuit, it represents phase shift oscillator using transistor. Okay, transistor is connected as an amplifier here, and here you can observe in the feedback network it is having a ladder type RC network. Okay, this is R, C, R, C, R, and C. Okay, you can observe in this we had studied this principle of oscillations in the previous class, isn't it? That is Barkasian criteria. What is the two statements it states is over the loop, over the complete loop, it has to it should have a phase shift of 0 degree or the 180 degree, sorry, 0 degree or 360 degree, isn't it? Complete loop starting from the input through amplifier again through the feedback network back to the input, it should have a phase shift of total phase shift of 0 degree or 360 degree, isn't it? Here the amplifier, it will provide a phase shift of 180 degree. Okay, this is an inverting amplifier. Input you are giving it to the inverting terminal, so whatever the input you give here, okay, so that output it will be inverted. So here it is happening 180 degree phase shift it is. Okay, now the feedback network what we have connected in phase shift oscillator, we had used 3 RC sections, isn't it? So you have a 3 pairs of RC. Okay, so each RC section in the feedback loop, it provides a maximum phase shift of 60 degree. So it is provides a maximum phase shift of 60 degree by each RC section. So you have 3 RC section, so total of 180 degree phase shift it will be provided by a 3 that feedback network which is connected here in the phase shift oscillator. Okay, each of the RC sections in the feedback loop can provide maximum phase shift of 60 degree oscillations occurs at the frequency for which the total phase shift through the 3 RC section it will become 180 degree. And as I said, the inverting op-amp is inverting, so it provides a 180 degree phase shift. Here also the transistor it is an inverting one, so it will give you 180 degree phase shift. So this meets the requirement for oscillations, that is of a 360 or 0 degree phase shift around the loop. Okay, so for 3 equal RC sections, the attenuation factor is beta, which is equal to 1 by 29. So this beta can be written as Vf divided by V naught, is it not? Vf represents it is a feedback signal and V naught is the output signal. So input to the feedback network is V naught and output from the feedback network is Vf. Okay, so to meet the conditions for oscillations, so that is by Barkasian criteria, we can write, that is to get the sustained oscillation it should have A beta is equal to 1. Therefore if you take beta is equal to 1 by 29, it should have A beta, magnitude of the gain should be equal to 29. Okay, so beta is equal to 1 by 29 you will get according to this. Okay, to meet the Barkasian criteria, the another condition will be having a gain is equal to 29. So the voltage gain of the amplifier must be equal to 29. Okay, that how you can write is here in the inverting amplifier, this one phase shift oscillator, the gain is given by feedback resistor RF divided by input resistor R1. Okay, this represents the gain. So the voltage gain of the amplifier must be 29. So that is, since it is inverting, we write the gain as minus RF by R1, which will be equal to 29. So RF should be is equal to 29 times of your R1. So this is the condition to design the phase shift oscillator, RC phase shift oscillator. And that too, this is for sustained oscillation. Why? Because we are considering A beta is equal to 1. So the frequency of oscillations in case of RC phase shift oscillator, it is given by, so it is given by F0 is equal to 1 by 2 pi RC root of 2 into N. Okay, so this is the equation to find the frequency of oscillations, where this N represents number of RC sections. N is here number of RC sections. Okay, since we are using here N is equal to number of RC sections is equal to 3, we'll substitute this N is equal to 3. So frequency of RC phase shift oscillator, it will be 2 pi RC, 1 by 2 pi RC root of 6. Okay, this is the equation to find the frequency of a RC phase shift oscillator. So it is a derivation is not there for this equation. Okay, this is not having derivation. We have a Wien bridge oscillator. Next, for RC phase shift derivation is not there, frequency derivation. It is there for Wien bridge, that we'll see now. Okay, so this is for phase shift oscillator. If you get a question, explain RC phase shift oscillator, you have to write the block diagram. You have to write the block diagram, and so this amplifier can be constructed using either op-amp or can using a transistor, and here each RC section it will give a phase shift of maximum of 60 degree. So from the feedback network you will be getting a phase shift of 180 degree. To meet the Markation criteria, the amplifier it will give 180 degree phase shift. So total of 360 degree phase shift it is happening. So now the feedback factor, attenuation factor, it will be given by beta is equal to 1 by 29. Okay, that is nothing but Vf by V0. Okay, this is with respect to this RC networks. To meet the Markation criteria, A beta should be is equal to 1, hence again it will become 29. Okay, considering this operational amplifier circuit, we'll get minus RF by R1 is equal to 29. So this is the design, this is the condition for designing RC phase shift oscillator, that is RF should be is equal to 29 times of your R1. Okay, and the frequency of oscillation in case of phase shift oscillator, it is given by F0 is equal to 1 by 2 pi RC into root of 2 into N, and this N represents it is number of RC sections. So here we are taking it is 3, so F0 will be equal to 1 by 2 pi RC into root 6. Okay, this is what you need to write for RC phase shift oscillator.